Welcome back. We're finishing up our zombie apocalypse. As you can see, I painstakingly went through 15 days of the zombie apocalypse, and it got down to the last 8 with in about days, and then 5, 3, and then one person, 17, lasted a full day by his or herself until by day 15, all 100 people that we started with turned into zombies. Now, to get a model for this, we would take our data, and we're just want to compare the day number to the number of total zombies that day. And so that was just the first and last column from the page before. Type all of this in. We type day number into L1. Total number of zombies into L2. We did that by hitting stat, and then number 1 was edit. This is all on page 51 of my booklet. And then what I did was I went and did a logistic regression. So I went stat, scroll over to the right to calc. I like to go up to B, which is logistic, and stored into our regular. You stored it into 1. Remember that Y1 is alpha trace and then enter. And then when I did that, it takes about 3 seconds if you're trying it at home. It gives me this looking equation where I have C on the top of a fraction and bottom 1 plus A E raised to the power of negative BX. And so I'm given A, B, and C. E is actually a number. It's kind of like pi. It's one of those weird irrational numbers that we have in our universe. And then I wrote it out like this with my C value on top, that 99.604, 1 plus my A value of 378.111, E raised to the power of negative B, which was 0.833x. So what I can do from here is I want to graph it and see how well it fits our data. So I'm actually just going to turn my scatter plot on. I hit second y equals, and we'll make sure it's on. I like to use, we want to scatter plot, so the dots, L1, L2, I like to have the color blue. And then we're going to go zoom 9 to zoom to our statistics. That is right here, zoom 9 zooms to our stats. Type the equation y equals. We also have that there. So I have the boxes are my data points, and then we see our beautiful logistic curve right there. So we got this question, how well does the function will fit the data? So the model fits our data very well. As the line goes through every point. So we talked a little bit about scatter plots last unit, and we see that this line models this data really well as it goes through it. It's really strongly correlated because the line follows all those points. They're all really closely connected to those lines. Hopefully you've been looking at Canvas and you're getting links from me and your teachers about how to have access to a TI calculator. If you can, we want you to try and practice this, where you'll type in your data for the years after 1990 into L1, and then the Jewish population in Toronto at L2, and sketch it. It won't exactly look like this because we're not going from 0 up to the max, but you'll see what it looks like, and you'll try and explain what if you think this function provides a good fit for the data. If it's nice and close, this was a good fit for our data here. Number 9 says, what's the limiting value? And then over here on page 50, we have that C represents the limiting value. That's kind of like the maximum. So in our zombie apocalypse scenario here, our limiting value, the maximum of zombies we could have was 100. Have any more than that, and that's what this 99.604 told us. This was our our leading value. And that was pretty much 100 because we could only have a maximum of 100 people turn into zombies. We only started with 100. And then finally, what will the Jewish population in the year 2021? This will be, remember, X is going to be the years after 1900. So you have to figure out what your new X would be. And then I suggest using, maybe your equation should be stored into y equals, and then going to look at your table. Remember that second graph. And you can try and do that. And if you don't have access to a calculator, get in touch with your teacher and we'll try and make it happen for you. All right. That was 7.1. See you next time for length of daylight 7.2.